Welcome back. Today, very exciting, we get to start our study of three-dimensional solids and polyhedra, which gives us right away a new vocabulary term, polyhedron. Now, a polyhedron is a three-dimensional solid, so it's kind of like a shape, but instead of a 2D, it's 3D. There are certain rules of what we get to call a polyhedron and not. A polyhedron has to be made up of polygon faces that meet together to form edges and vertices. So the simplest way to look at a polyhedron would be to see a prism. So let's draw a little doodle, have ourselves a doodle here. So this would be an example of a prism. It's a simple polyhedron. You can see all of the different faces, the different sides of it. They are polygons, some are triangles, some are rectangles, and they all meet together to form the edges and vertices. Now a prism, like I just said, is this specific type of polyhedron. Now prism has two bases, and they will always be congruent to each other, and they will always exist on two parallel planes. Very important. The bases are connected by a series of rectangles. Now we name a prism based off of the shape of the base. So in the case of this example, my base is a triangle, so this would be a triangular prism. If the base was a rectangle, it would be a rectangular prism, or a hexagon would be a hexagonal prism. Now when the base becomes a circle, our definition breaks down. Because circles are not polygons, they can't be part of a polyhedron classification. So this object instead is called a cylinder. Alright, so with all the boring definition stuff out of the way, let's get started. Now what we're actually going to be doing with these prisms and cylinders is we're going to be calculating volumes and surface areas. Now the volume for an object, we'll focus on the prism for now, is always calculated the same way. The volume is equal to the area of the base times the prism's height. Now the area of the base is obviously going to change from prism to cylinder and whatever you're working with there, because the base is always going to be a different shape. So it could be a triangle, it could be a rectangle, it could be a circle, whatever you're working with. You're going to have to choose the correct formula for finding the area of that base. And the height is the distance between the planes containing the bases. So in this case, the height of this prism would be 12 meters. So we'll throw a few more numbers on here so that we can actually calculate the volume of this thing, and off we go. So the area of the base for this triangular prism is just going to be the area of this triangle down here, and that's a nice right triangle, so it has a nice, easy to calculate area of 6 square meters, and then the height is 12 meters, so we get a volume that is equal to 72 cubic meters. And that's it. That's volume. Surface area is a little bit different, a little more roundabout. I like to think of surface area as the perimeter, but in a three-dimensional sense, meaning that there isn't a formula that you're going to follow like there is for volume. Instead, to find the surface area of a prism, or really any three-dimensional object, you simply take the sum of the areas of all of its faces. So in this case, we've got 1, 2, 3, 4, 5 bases. So if I want to calculate the surface area, which we'll abbreviate as SA, of this object, I'm going to need to find those 5 different areas, add them all up, and see what we can get. Now, the easiest way to do this usually is just in a piecemeal manner. Find the area of each of the faces on its own. So I've numbered them 1 through 5 just to simplify talking about them. If I can find all 5 of these areas, then we are golden. So the area of face number 1, it's a triangle, so half the base times the height is going to be 6. 5 is congruent to it because of the two bases of my prism. Now face number 2 is the one that connects these hypotenuses from my bases. So it is a 12 by, it's a 3, 4, 5 meter. So that's going to be 60 square meters. Base number 3 is on the bottom, So it's a 4 by 12 rectangle, making that 48 square meters. Face 4, I've got on the back side here, which is a 3 by 12. So we have an area there of 36 square meters. So we get to add these all together, and we get our surface area is equal to 156 square meters. And that's surface area. You just have to keep track of all the different faces and their areas, add them up, and you're good to go. Now, the only issue that you might run into when calculating surface areas is dealing with cylinders, and specifically the lateral area of a cylinder. So let's draw a little cylinder here. Show what I'm talking about. Now, if I were to ask you to find the surface area of this cylinder, let's say it has a radius of 2 inches and a height of 7 inches, finding the surface area would be the sum of the 3 faces that it has. You've got the 2 circles, one on top, one on bottom. So it's going to be 4 pi times 4 pi. Well, plus 4 pi, I suppose, since you're adding the faces, not multiplying them. And then you have to add in that third area, this sort of sleeve that goes around the cylinder. We call that the lateral area usually. Now, that lateral area is a little bit harder to calculate because it's not a simple rectangle like we had with the prism. But you can treat it like a rectangle if you are clever. What we can do is we can think about just cutting, like with a pair of scissors, down one of the edges of the cylinder and then unrolling it like a sheet of paper. So our cylinder can be sort of rolled out. If we just think about it as just that sleeve, we can unroll that wrapper and we get it as a nice rectangle. Now the height of the rectangle is going to be the same as it was on the cylinder. So the height of that rectangle is still 7 inches. But the question becomes, what is the length of this rectangle? Well, when the rectangle was still rolled up around the cylinder, that length was this top sort of rim that goes around the circle. This is the circumference of the circle that you're working with. So that lateral area of your cylinder is just the circumference of your circle times the height of your cylinder. So in this case, the circumference is going to be 4 pi because it's pi times the diameter, and in this case, it's just going to be times 7, so that's going to be 28 pi. So we get, what is that, 36 pi inches square for our surface area. And there you go. With those two things in hand, you should be well on your way to prisms and cylinders. Thank you very much for watching. Good luck and have fun.